Assalamualaikum and good day everyone. We continue our discussion with the macroscopic view. In macroscopic view, we want to analyze what will happen to the group of atoms in a dielectric. So let's say we have a dielectric here, and at this moment, this electric field is not applied to this material. So I'm going to write here E applied is equal to 0. And next we have a material and we introduce electric field to this material. So I'm going to write here E applied is not equal to 0. So as we know in the microscopic view that E applied will introduce electric dipole moment in a single atom. So what will happen here, okay, let's say we assume that we have n atom in this dielectric. So I will give a number to this n. Let's say it is equal to 4. Okay. So this is under the assumption. Okay. What will happen here? I can draw that there will be 4 electric dipole moment because we have 4 atoms here. Okay. So this will be our first electric dipole moment. Okay. Second, third, and fourth. Okay, the direction of this dipole, electric dipole moment is equal to this E applied. We will follow the direction of this E applied. Okay, so from here, okay, from this scenario, I'm going to write a new equation. Okay, a new equation where this one is equal to the capital P. This is a vector. Okay, and equal to the limitation volume near to 0. And here the summation of our electric dipole moment in that material. And now we have I equal to 1 until 4. This one is based on this scenario, because now the n is equal to 4, so I write it into the 4. Okay, then this one we divide by delta V. And this new vector known as polarization vector. Polarization vector. Okay, and for this situation, the P is not equal to 0 because we have the E applied. However, for this material, when the E applied equal to 0, P will be equal to 0 as well. Okay, and now we can say that this material is known as polarized dielectric material. And for this one is unpolarized dielectric material. So as a conclusion for this, when we apply E to this dielectric, it will introduce the electric dipole moment And due to this situation, a new vector is introduced, and the vector name is a polarization vector. And when we have this kind of scenario, that material is known as polarized dielectric material, while when there is no polarization vector in this material, we will call this material as unpolarized dielectric material. In the previous slide, we get a new vector which is a polarization vector. Now, we need to investigate how the polarization vector is related to the electric field. Here, I'm going to introduce a new formula where this is the P equal to the electric susceptibility epsilon naught E. This is how the P is related to the E. Okay, and this one is the electric susceptibility. Okay, this constant showing how sensitive a given dielectric to the electric field. Okay, from this, I can conclude that when E is introduced to the dielectric, this E will introduce a new vector. Okay, this E will introduce a new vector in that dielectric, where that vector is the polarization vector. And this polarization vector is actually introduce a new charge. Okay, so this one, it introduce a new charge. And that charge is known as surface charge and volume charge. So, I'm going to talk about these new charges in the next video. So, that's all for this video. Thank you.